we are discussing about the effects of gaseous pollutants on human health. Today, we will discuss more on the aspect of particulate matters. More importantly, or more specifically, the mechanism of lung injury caused by PM10. As I said, it's no longer necessary nowadays. It is told as silica 5 micron or something like that. We generally consider this to be PM10. This is the standard nomenclature now. Nobody talks about silica 5 micron silica or things like that. That are usually popular in various terminologies like in mining. So here, as I think I have discussed about this PM10, how we explain the PM10. Now, having said this, just let me explain you this, how these effects take place. This is, say, first of all, in the airways, there are three mechanisms actually by which this the PM10 influences the human health. First is airways. This is, as you know, this, particularly as I was discussing, the defenses of pulmonary airways comprise the mucociliary which is mucociliary escalator. That means the upward movement by the mucus and cilia present in the pulmonary airways. So here this mucus traps the dust, traps the particulates, and this mucociliary escalator pushes the entrapped particles up so that they can be spat. They can be spat outside. They can be spat outside. This is the epithelial cells which house the cilia, and which keeps the cilia and cover them and remain covered by mucus, which house the cilia's and remain covered by the mucus, are susceptible to say this particle stimulation that causes allergy. So just what I have said essentially, as I was discussing yesterday, the same phenomena, these particles, the air particles, what they happen is, as I have said, in this this bronchial trough, that is through which this a part of that is the pulmonary system, pulmonary is airways, all that linked with the airways, lung and all these things, these are related to pulmonary airways. These pulmonary airways have epithelial cells. If I remember, if we just said, I said that the cells are like this, they are connecting like this, you have the nucleus in the cells like this, large cells, large singular or a combination of cells like this, these are the epithelial cells. Within these epithelial cells you have these cilia's, within the cilia's, as I have said, within the cilia's, and of this cilia's, this part is where it should be covered by the mucus. So it's covered by the mucus. So this particularly, as you can see, this tract like this, and this tract like this, when the particles are trapped in it, there's the typical say muscular movement, the muscular movement forces the particle and the mucus, these particles and the mucus here, to move up so that they can be spat outside. So wherever they are trapped, these epithelial cells which house the cilia's and covered by the mucus, after it is trapped by the voluntary action itself, they can move up and come to the saliva, and that can be spat out. This typical thing, what happens when the dust enters in your throat, the kind of things that you generally do. So this is what is this particle stimulation that causes allergy. I mean, so sometimes this particle causes, depending on the subject, depending on the whether there is a person having some bronchial disorder records, or their type of exposure, the people would be the effect would be that way, I mean, prominent. So some people would be extremely sensitive to these allergens. The particles would be immediately act as allergen. Say people like me, people like you and me, maybe even if we have a good amount of dust in the mines or anywhere where there is a lot of dust, we generally are not very sensitive. Our system may be somewhat more immune, but there are so many people who cannot tolerate a small flakes of dust also. For them it becomes extremely difficult to survive in such situations. So this is what I said. This is the typical mechanism that the mechanisms that by which the particularly the dust particles would be arrested in the airways and will be moved up. So there are few more. This is if you can just observe now, there would be terminal airways. This is if it has slipped, say if the dust particles have moved further from the airways, it would move to the terminal airways. terminal airways and proximal alveoli. Proximal alveoli. Where what happens here is once the particulates small particles are called particulates. So you just remember this, only the small particles. Once the particulates escape through the airways, they deposit in the terminal airways and proximal alveoli. Proximal alveoli is the proximal. The word proximal is very close to lung, as the volume increases. See, as the volume increases, what happens is as the volume increases, the speed, the velocity of the particles become close to zero, and they begin to settle. They begin to settle, and proceed, and with time they proceed to the stomach. Increased incidence of such particles, can provoke morbidity and finally mortality. So here is finally mortality. As such, it is. So it very simply can be said as to increase to this mortality. So you can see here. So essentially, all this, finally, they can. Some of them would be depositing in the terminal airways, and as a result of this terminal airways, it would reduce the capacity of the lung. If it is continuously exposed like that, a person having, say, a child going to school, every day he is getting exposed to, particularly those children who are traveling by bus, say, long distance. They are through a dusty road. they are getting exposed to the dust continuously over time, right? This particular kind of incidences where there are some periods when they will have a heavy dose of these particles over time, continuous exposure to this kind of situation might lead to the morbidity of some of the intestinal as well as bronchial parts. Okay, intestinal and bronchial parts. So this can result into this kind of disturbances, which can finally lead to death. Let me explain how this particularly in a pictorial form. Let us explain how these things takes place. See, this PM10 related mortality, PM10 related morbidity and mortality. This is PM10, PM10, this is PM10 particles. PM10 particles. This arrow meaning that it is entering to the pulmonary airways. This is say pulmonary airways. Pulmonary airways, so would lead to say finally would lead to this, it can lead to pulmonary inflammation, pulmonary inflammation. This pulmonary inflammation, from this, if you can just see, this is okay. If we come to this side, release of cytokines. Release of cytokines. This release of cytokines, I am coming back to that. On the other side, there should be, on the other side, this one is decreased PMN deformability in the pulmonary microcirculation. Pulmonary microcirculation. PMN stands for polymorphonuclear neutrophil leukocytes. Leukocytes, these are mostly these leukocytes. These purpose is they are important mediators for lung injury. What happens is this pulmonary inflammation that is taking place, as I have said, increased incidence of these dust particles would lead to decreased PMN deformability in the pulmonary microcirculation. What happens here is this PMN is the polymorphonuclear neutrophil leukocytes. These are the the components of the blood, leukocytes. So typical leukocytes. These leukocytes, what happens is they generally work as a mediators for lung injury. That means they resist the lung injury. You know, whatever the dust particles are there, you know, they would immediately they are tuned to resist the dust being entering the bloodstream. So what happens is consistent exposure of dust makes them ineffective. Their deformability, decreased PMN deformability in the pulmonary microcirculation, that is continuously, this is one effect that relates to the decreased deformability, decreased PMN deformability of the microcirculation. Here this one, finally what happening is that as a result of that continuously, as you can see this, continuously from this, you know, this would lead to the deformation change. This would lead to the changes which I am coming back, you know, I will come back to this again. This one is here, there are this particularly pulmonary inflation would reveal, you know, a particularly is, you know, this exacerbation of airways disease. What happens here is, just try to understand, suppose, you know, you have already a patient suffering from COPD or say asthma, this would increase. Exacerbations means, you know, this would be particularly asthmatic patients would be having more higher say, you know, the rhythms of heart and rhythms of lung, you know, where it would continuously vibrate at a higher speed or at a higher frequency. So this kind of exacerbations increase. This is pulmonary means, you know, increased effect on this pulmonary inflammation would finally lead to exacerbations of airways disease, particularly related to COPD and asthma patients. This release of cytokines, the release of cytokines, you know, these are body antigens which would directly impact the liver. This is as this release of these cytokines. These cytokines are body antigens. These body antigens would essentially impact the liver. So this liver, from this liver, as you can observe, it release of blood coagulant, you know, no dash actually, blood coagulant factors. See what is happening here. See, pulmonary inflation, increased pulmonary inflation. This is the release of cytokines. The release of cytokines in the liver would mean would essentially mean that the blood would begin to coagulate. What happens to the blood beginning to coagulate? As I was discussing, you know, so blood is essentially an emulsion. Any emulsion is not a perfect mixture. If you know that emulsion is, you know, is remained as a, you know, at a particular temperature, at particular potential, they remain within the solution. It is not a mixture. So what happens is they are extremely sensitive to impurities. See, that is why, you know, this most of the cases the milk is particularly a good example of emulsion. If you just drop a drop of a lemon, it immediately coagulates. the particulates coagulate. So, the emulsion structure breaks and it begins to coagulate, it begins to stick together. Okay, that is what you know of, mostly the substance, this is particularly begins to take place, the release of blood coagulants. This would lead to the blood forming to say this coagulate. Now, if the exposure is limited for a, say, for a small time, say not for a very critical time, then the person can survive, because after some time again, when this is brought back to a normal air environment, he begins to breathe, again the oxygen level rises, again the clot dissociates and begin to take place. In situation he can again survive. But if it continues like this, all this finally would lead to, all this would finally, these two things would lead to is all these two things would lead to coronary and cerebral microcirculation. Coronary and cerebral microcirculation. You can see this, what started in the lung is finally traveling to the heart. Okay, what started in the lung is essentially traveling to the heart and finally to the head, cerebral microcirculation. This would finally, this is from here, if you just see from here, the increased effect of the dust PM10 here would be this particulates here would be, this would lead to hemostasis and clot formation. Hemostasis is a state at which the normal properties of blood get changed and the blood begins to form clots. These clots, excess of these clots would result to heart attack and stroke. So this is heart attack and stroke. So you can see the excessive incidence, excessive exposure to dust can finally relate to a heart attack and stroke. But remember one thing, till this point, if you can see this, till this point, if this is temporary, I mean is for a short duration, the person can again get back to its usual position with certain medication or certain physical helps, certain forced breathing, and a person can be, and increased supply of oxygen can lead to the person to go back to effective normal position. But on the other hand, if it does not remain like this, so this kind of situation takes place when? Just to give you a simple example, when this kind of things can take place. This kind of things can take place when suppose a person suddenly, say a large quantity of dust is thrust into somebody's mouth, or a large amount of dust is in a very dusty environment, he is working in a very dusty environment and consistently being exposed to that. So if he is in the dusty environment, he cannot stop breathing, it has to stop, he has to breathe, and if he breathes, these are the excessive these are the reactions that are likely to take place. These reactions, when they continue over a long time, over a reasonably long time, depending on the concentration of dust, can lead to death. So this is what is the role of PM10, which is in many cases in mining situations, or in kind of workers related this thing. See here, as you can see, if it is in this place, if you just observe, this can say what we have known of, say pneumoconiosis or silicosis kind of diseases, which are now differently known. These are essentially creating morbidity, a certain dysfunction or and no function at all of a certain body part, body organs. So the one lung may be completely damaged, or the lung capacity has been completely derated. Lung capacity has been derated for the whole life. Nothing can change it. So when the process is, the effect is permanent, we would call them morbidity. But this morbidity can overall gradually this morbidity can result into functions like mortality as well. If you remove, mostly there are very critical and very sordid examples are those people who are the miners who work in particularly say marble mines, slate mines, mica mines. These people when they start with morbidity, but finally they die with mortality at a very young age. So particularly if you go to Rajasthan side, there are about 1,000 marble mines, and in those 1,000 marble mines, the life of the worker at best would be about 40 years. So they might be joining the workforce at 12 years or 13 years. By 31, 32, they would be prematurely aged, and they would be by 40, all of them are dead. This happens, on different situations also. Like, if you see the rickshaw pullers, try to see sometime the rickshaw pullers. If you observe the rickshaw pullers, most of them, those whom you see in IIT Kharagpur or any areas like that, their age would be mostly about say within 40. Very few rickshaw pullers you would say would survive say the age of 50 years or 55 years or 60 years. They don't survive. So the condition is, this is what I am saying, is that consistent exposure, episodial exposures when there are large exposure for small time, but over a long duration, over a long period of time, they can generate morbidity in the first place, and from the morbidity itself they can generate mortality. Suddenly that you can see the other habits are also important. Say if he is a smoker, or if he drinks, or he uses some other say the substances like tambaku and all other kind of stuff that he can take, all this situation, they together can be aggravate the situation. The situation can even go worse. Okay. So this kind of things, these are the likely situations that takes place, the related kind of diseases and the typical say the exposure related problems of most of this gas and gaseous particulates and the particulates. Okay, so I have mostly discussed of these health effects. I'll see as generally you will have some idea about what kind of health effects usually take place. Apart from that, there are few things I would like to just these are the things, say air quality standards. I would say mostly this you find this nowadays in the websites and any other places. This is for our country, the Central Pollution Control Board. The standards which are generally famous is another is National Ambient Air Quality standards NACS, this is which is this is USA and UK. Mostly there are some other permitted in the industrial concentration anyway. So these two please try to see, in all many websites are there already. You just write CPCB, Central Pollution Control Board, you will find many of these websites. Even most of the cases these standards are given, but just to give you some idea about what are their standard values. Pollutant time weighted average, industrial areas, residential areas, sensitive areas, so says the pollutants SO2 annual average, or 24 hours average. Mostly the values are 80 microgram per meter cube. This is essentially 80 microgram is about say 0.03 ppm. Residential areas is 60 microgram per meter cube. This one is 15 microgram per meter cube. 15. This is SO2, NO2 oxides. NO2 and oxides of nitrogen equivalent. NO2 and equivalent are say N2O3, N2O5, N2O, all this. These are annual average 24 hours average. These are say 80, 120. This is 24 hours, this is 120 here. This is 80, this is 30. So here it's okay, let me explain this. This is why 120, 80 and 120, 60, 80, these are similar. 60, 80 and 30, 30. Okay, what it means, why this thing, this thing annual average and 24 hours average. What it generally says is that, is can be in times is this annual average, you can see this, are generally less than the 24 hours average. It's always less than 24 hours average. It is to suggest that, there can be some peaks. There can be some peaks of these air pollutants at the time of the day, but here generally mostly the curve should be like this, and sometimes it can peak, but it should remain like this. So over a long time it should have a generally a lower value than the incidental peaks. There may be some peaks during some time which can increase. Say, even in this 24 hours average, say, day and night included, it should be it should not be more than 120 microgram per meter cube. So here, on the other hand, the annual average is only about 80 microgram per meter cube. So the annual value should be less than the episodal, the typical standard values like this. Okay, SPM annual average 24 hours, $360, $500. This is $364, $140, $200, $140, $200, and this is $70, $70 and $100 microgram per meter cube, and this is respirable RPM. All this RPM is PM10 and less. Remember this. This is PM10 and less. PM10 and less. Say PM 1.25, they say generally comes out with the exhaled breath. So about between PM10 and PM say 1.25. Anything less than 1.25, 1.25 actually comes out with the exhaled breath. So even if it is a dust, it would come out. So here RPM would be RPM, as you can see, this is annual average and 24 hours, annual average and 24 hours. It is about say annual average, and this is 120, 150, then 120, 150, 60, 100, 60, 100, 60, 100, then it is 50, 75, 50, 75. So you can see about 30% of this SPM, about if in any SPM, suspended particulate matter, about 30% would be RPM. About 30% would be RPM. So finally which one is respirable. So there are few more, lead and carbon monoxide. I would just ask you to read that, lead and you see carbon monoxide, lead and carbon monoxide, these are there. So this can be say particularly lead and CO, please see them, or otherwise I will sometime give you. So this is mostly, these are others are lead and CO, which are of importance. So we just generally have quite a good understanding of what are the values like. For generally, these are the things which are generally asked and which we should know also. This gives us the standard values for which this in any kind of exposure related pollutants, what are the typical values for that they should have in the air, suspended in the air, is given by these standards. So these standards finally have come through the different experiments. If I find time, I have a material to suggest how these standards are come about, but that would be a different story, a long story at all. So yes, okay, we complete this. So in today's class this much.